Welcome to this ChemistStream tutorial on running a LAMMPS example in the cloud. As always, you can get to the ChemistStream documentation and see the other tutorial movies here. And we'll assume that you've already started a remote cluster, started a ChemistStream server on that cluster. So let's take a look at those instances. And here they are. One master node and 3 additional compute nodes. And here's the notebook that was used to create the cluster. We're running at AWS, 4 nodes, and we're starting up the image with ChemistStream and LAMMPS. This is a notebook that was used to create the remote Jupyter server. And these steps created this link, which is used to create this remote session. Let's go to our shared directory. There are no examples there. So now we're ready to load our LAMMPS example. This notebook is used to push examples over, and here are some images representing some of the codes that are supported by ChemistStream. Let's execute these cells, and here's a cell to push over an examples directory into our shared cluster. Now locally, we have some directories set up with examples. Let's go to the LAMMPS example. Here's a notebook to manage the workflow, 2 input files, the setup configuration for the peptide test, and images for the notebook. So let's execute this cell. And now check our remote container. So there's our example. So let's start up this notebook. And here's some code to first run some parallel scaling tests with various numbers of processors. And here is the command template to run all of those jobs. And a bit of Python code to run in a loop and issue system calls to the Linux container that we're running on. So let's start that running. Take a look at this input file. We're running a large system here so we can get good scaling results in parallel. Making a short run, dumping out images in a container that has been configured to use this capability of LAMMPS. And let's return to our running session. Now, as always, you don't have to use this notebook for the workflow. You can start up a terminal directly inside this container. Here's our Python setup, our shared directory, our links to the LAMMPS executables, and our hosts file that can be used to run MPI jobs. And this is generated dynamically when the cluster is created. So back to our running parallel scaling jobs. Let's take a look at one of these log files. And we'll be parsing out the loop time to determine the performance. And we'll skip ahead here. Now all the jobs are done. Now we have some Python code to grep the log files and scrape off the timing information and generate a timing plot. So here we are up to 32 processors. And let's change the scale here to a log-log plot. And we can see that we have good parallel scaling performance over the range of processors used in this test. Here's one of the images generated. You can see the peptide test with the replicate function used to create this large system so that we could see good parallel efficiency. Now, just to illustrate how one can use a combination of the simulation code, post-processing, and ChemiStream. We have a very small test here set up with a longer run, and using the movie capability in LAMMPS with a LAMMPS build that has been configured to use this, and an image with an environment so that we can make videos, but display those videos with a player in Jupyter Lab. So now that's done. Let's start up that movie. And we can see the single peptide molecule being advanced in the simulation. Please check out the other tutorials on the ChemiStream documentation page, and thanks for listening.